Welcome students. Today we'll see the lesson number 2, algorithms and flowcharts. Now let us see what are algorithms and flowcharts. Out of which let's focus on algorithms to begin with. Now students, we all follow some rules to perform any work. For example, we don't just get up and go to school in our night clothes. Do we? No. You people get up, brush your teeth, take bath, etc. and then go to school. So these are few steps that you follow in your routine life to achieve the goal of reaching school. So similarly, a computer needs a set of steps or instructions to perform a task. Now these instructions are called programs. Programs are steps written in sequential order to obtain the desired output. Now these steps can be designed using algorithms and can be pictorially shown by flowcharts. So what is an algorithm? An algorithm is a step-by-step procedure to solve a problem. It is basically a concept that is used to create a new program. To solve a mathematical or computer program, the first step is to start writing an algorithm. Now, algorithm is pictorially explained here. To reach the desired output, first we have to give an input and set of rules to obtain the expected output from a given input is our algorithm part. And by following this algorithm, we are going to reach our desired output. Now let us see rules for writing an algorithm. An algorithm should be written in English language. Use simple language and precise words so that everyone can understand while reading. Use one instruction at a time. Use an input to write algorithm. Write the steps in sequential order. You can use variables and mathematical formulas for calculations. Steps should be executed within limited time frame to obtain results. The expected output should be checked using some sample values. Let's see the features of an algorithm. Input. The algorithm receives an input. Then it starts the process. The algorithm processes the input using different functions to achieve the desired output. Output. After proper execution, an algorithm must get desired output. Now, your algorithm should have a uniqueness, which means each step is uniquely defined and the output is dependent on the input of the previous step. There has to be finiteness. An algorithm stops after finite number of steps after reaching the desired output. If finiteness is not there, what will happen is when you put it into a program, when a program is made based on this algorithm, your program will get hanged. Most of your games and some softwares, they suddenly hang in between. Now hang means what happens? They go into a loop and they never come out because those loops are infinite. So your algorithm should have the property or a feature of being finite. So to sum up, the characteristics of an algorithm are: you should have well-defined inputs, clear and unambiguous. they are language dependent, feasible, there has to be finiteness, and only then you will have well defined outputs. Now let us see what is a flowchart. A flowchart is a pictorial representation of the steps of an algorithm. Now all the steps that you are going to write in algorithm, we are going to pictorially represent them using a flowchart. Now flowchart uses different symbols and shapes to represent steps which are connected to each other by arrows which show the process flow. Since it is a visual process, it is easy to understand a program. Let us see some common flowchart symbols and their functions. The first symbol is a oval shape, which is used to represent the start and stop of the flowchart, also called as terminal. Next is flow lines or arrow. Now they are used to connect the symbols used in flowchart and indicate the direction of flow. Next is a parallelogram. Now parallelograms are used to read input data and output display information, also called as input output. The next is a rectangle. Rectangles are generally used to represent process. For example, arithmetic operations, data movement, etc. So the symbol name is process. Next is a diamond shape. Now diamond shapes are generally used to check any condition or take a decision for which there are two answers. They are yes or no, which is true or false. So this symbol is called decision. The next is connector. Now the connector is used to connect or join flow lines. The next symbol shown is annotation. Now annotation is used to provide additional information about another flowchart symbol in the form of comments or remarks. Features of a flowchart. Flowchart should have only one start and one stop symbol. The flow in the flowchart should be from top to bottom or left to right. The flow lines should be connected to the symbols or other flow lines. If flowcharts are long or use more than one page, then on-page or off-page connector should be used to continue the program flow. Now that you've understood the concepts of algorithm and flowchart, let us see by an example. Now we'll write an algorithm to find whether the given number is even or odd, and based on that we'll also write a flowchart to find the given number is even or odd. Now let us see how we write the algorithm and how we pictorially represent it using a flowchart. So to begin with, step 1 would be input a number A. Now step 2 is going to be calculate B, which is equal to A divided by 2. Step 3, if the remainder is 0, the number A is even. Then go to step 4, else go to step 5. Step 4, print A as an even number. Step 5, print A is an odd number. Now with that same example, to find whether a given number is even or odd, we have written a flowchart for it. Now look at the start button. It is oval in shape. Also look at the end button. This is also oval in shape. So this oval shape we use to write start and end. Those are called as terminal symbols. Once the program starts, then we have drawn a parallelogram wherein we have written input number A. Now that was the input box or output box is drawn with the help of a parallelogram. Next, we have drawn a rectangle where we have processed that number A. We've written there B is equal to A divided by 2. Now this is the process which we are going to do to find whether the number is even or odd. Next is a decision box. Okay. Now what is written in the decision box? If B is equal to 0 or B is not a 0 number. So if B is 0, then it is A is a even number. If B is not 0, which means if the remainder is not 0, then B is an odd number. If it is even, in the output box you will get the message A is even number. If B is not 0, in the output box you will get a message B is an odd number. And the program will end. It will stop. Now, with this we come to the end of this chapter. Let us take a review as to what we've learnt in this chapter. We learnt about the definition of algorithm, features of algorithm, rules for writing an algorithm, an example of writing an algorithm, definition of flowchart, common flowchart symbols and their functions, features of flowchart, and an example of drawing a flowchart. With the same example for algorithm, we used to draw a flowchart.